Your goal while watching this video is to be able to take a factor out from an expression. This is kind of like undoing the things we've been doing in the last two sections. So, as you are watching this video, make sure that you are filling out your notes as you go. I will be collecting those in class, and here we go. Okay, so first, to refresh your memory, a factor. So factor, you've talked about greatest common factor in the past. You've talked about factor trees. You've talked about prime factorization. So what is a factor? A factor is a number that can be multiplied to get another number. So why don't you pause, get that written down. Instead of saying a number, I decided to say something because now that we're in algebra, that factor could be x, okay? So I could say that if I had the number 6, and you do not need to write this down, but its factors, or the numbers that I can multiply to get 6, are 3 and 2. We could also do 6 times 1. All right, so this is a factor of 6. This is a factor of 6. This is a factor of 6, and this is a factor of 6. We could say that if we had 6x, all right, we could multiply 6 times x. So 6 is a factor of x, or of 6x. X is a factor of 6x. We could also do 3 times 2x. So these would both be considered factors. We could also do 2 times 3x. So these would also be considered factors of 6x. So make sure you have this definition of factor written down before we move on. Okay, so we're going to start really simple, all right? We've been looking at things like this, 2 times the quantity, 3 plus 1, where instead of doing what's in the group first, we distribute the 2, and we say, okay, we could also do 2 times everything in that group. So 2 times 3, which is 6, and 2 times 1, which is 2. So all we're going to be doing here is working backwards. We have 6 plus 2, so we say, okay, what is a number that is a factor of both 6 and 2? The factors of 2 are just 1 and 2. Those are the only things you can multiply to get 2. Factors of 6 are 1, 2, 3, and 6. Those are the numbers you can multiply to get 6. So which factor do they have in common? Only 1. All right, so then what we're going to do to work backwards, or take a factor out, is we're going to take the factor 2 out. All right, so how many times does 2 go into 6? 2 times 3 is 6, right? And how many times does 2 go into 2? Just once, okay? So we just worked backwards and took the factor out, so it looks like distributing again. All right, so in this case, we're getting a little bit more complicated. We're adding a variable in. So we have 24x minus 18. So we need to take out a common factor that both of those have. So I'm just going to list my numbers. I have 18, I have 24. Okay, factors of 18, I can multiply 1 and 18. I can multiply 2 times 9. I can multiply 3 times 6. So far, all of these numbers are factors of 18. 4 does not go into 18. 5 does not go into 18. So that's our complete list right there. 24, what are the factors of 24? What are the things that can be multiplied to get 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Right, the only thing missing is 5, and 5 is not a factor of 24. So then we look and we say, okay, what are common factors? Well, they both have a 1. They both have a 2. They both have a 3. And they both have a 6. And that's where we stop. So we should always try and factor out the greatest common factor. So here are the common factors. The circled ones are common, things they have in common, things that are the same about them. So now we just want the greatest of those common ones, which is 6. So we're going to take 6 out. We're going to say, okay, if we took 6 out of 24x, 6 times what is 24x? 6 times 4 is 24, and we need that x term in there. Right, so we have 4x minus 6 times what is 18? 6 times 3 is 18. Okay, so basically, we just undid what they did up here. They had 24x minus 18, or 24x plus negative 18. We took out that factor of 6. Now, if somebody else was to come along, they could say, hey, I can't do what's in this group. So I could distribute, don't write this part down, all right, 24x minus 6 times 3, which is 18, all right, and they could bring it back to our original problem, okay? But when you factor out, your goal is to get it looking like this. Okay, factoring out a fraction. The nice thing about this chapter in the book is that when you have to take out a fraction, they're always going to tell you what it is. So you don't have to say, okay, we have 1/2 and 3/2. What are their common factors? Don't have to do that because that's really tough with fractions. So instead, they're going to say, hey, the thing you take out is 1/2. So if we were to factor out 1/2, what would we have left? So first, let's look at this first term, 1/2 x. 1/2 times what is 1/2 x? It's 1/2 times x. Okay? Then we have to say, all right, plus, how many times does 1/2 go into 3/2? So 1/2 times what equals 3/2? Okay? So remember, when you multiply fractions, you just multiply your denominator. So 2 times what is 2? 2 times 1. All right? We just multiply our numerators. 1 times what is 3? 1 times 3. All right, so 1/2 times 3 over 1, or just 3, is 3/2. So our missing number is this right here. And then it's done. All right, we factored out the 1/2. We worked backwards to the state that it was in before someone distributed that 1/2. Last example. All right, this is like record time for me. Are you impressed? Are you cheering? You should be. Okay, as long as you don't make this one take 5 minutes, this will be like one of my fastest videos. So factor -2 out of -4p plus 10. Okay, so again here, this is super nice. We don't have to find the greatest common factor. They're telling us. They're saying, hey, take out -2. Okay, so we wanted to get it back to its pre-distribution state. We want to get it back to what it was before somebody distributed and got -4p plus 10. So our first question is, -2 times what equals -4p? All right? We know, since this does not have a variable p in it, this is going to have to. So then I'm going to say, okay, -2 times what is -4? -2 times +2. So our first term, 2 times p. Plus, all right, -2 times what is 10? All right, well, I know 2 times 5 is 10. So if I put a 5 in there, -2 times 5 is actually -10. So I want +10, so I'm going to have to make this 5 have the same sign as this 2, which makes them both negative. So 2p plus -5. If you wanted to check your answer, you could distribute it again and say, all right, will this answer that we just wrote get us back to this expression up here? So -2 times +2p, is it -4p? Yes. All right, and then -2 distributed to this -5, is it +10? Yes. All right, and that's it.